The Elastic Stack, previously known as the ELK stack. The name was based on the three main components: Elasticsearch, which facilitates the log storage and searching, Logstash, which is the log collector, and Kibana, which is the graphical user interface used for consuming and exploring of data. At its core, Elasticsearch is a search engine. It's built to be highly scalable, and this is a huge benefit for storing and searching through large quantities of data. It's open source with a free basic tier that allows everybody to deploy it and use it. The Elastic Stack has become very popular with the security community, especially for its log storage and searching capabilities. Diving a bit deeper into all the individual components that make up the Elastic Stack, we'll first start with the logs that we want to store and analyze. One of the category of components not mentioned previously consists of the Bits log shippers. These are small applications that get installed on the sources that generate log data, and these will collect and ship the logs. Depending on the use case, this can also do some pre-processing. Logstash is the log collector, and it will collect logs from either sources that are able to send logs by themselves or sources that have Bits installed. The main component, Elasticsearch, is used to store, analyze, and search through the data that it received from Bits and Logstash. The way data is consumed and analyzed is through Kibana. This is a web application that provides all of the dashboards and some management capabilities. On top of Kibana, we have apps, which are individual and bespoke modules for logging, metrics, analytics, SIEM, and many others. Depending on the data that we're trying to analyze, we must consider that the logs come from various platforms in many different formats, and therefore we have multiple bits for each use case. Starting with WinLogBit, this can be used to parse and ship Windows event logs. Packetbit will sniff network traffic and parse it to extract flow and protocol information. FileBit is used to forward logs that are written into flat files. These are the main ones that we'll be using, but there are also many other bits, such as AuditBit, MetricBit, HeartBit, or FunctionBit. Now that we have a solid understanding of the main components of the Elastic Stack, let's look at the existing security solutions that are based on it. Inspired by its features, many security professionals and organizations have started to use Elastic to store logs for security investigations. In some cases, they also add additional components to enhance searching and analysis. Here are some examples of existing solutions, like the Helk, RockNSM, and Sofelk. References for these will be included in the course materials. Another important aspect we need to address is data consistency, as we may encounter problems when trying to correlate data from different sources, which are in different formats and contain different fields. ECS, or Elastic Common Schema, has been developed to address this problem. It's a standard naming convention for field names. The primary goal is to ensure consistency between log sources. And this is a must when we'll correlate data between different security capabilities. The good part is that ECS is already built into Bits and Elasticsearch with all the recent versions, especially from 7.0 onwards. To give you a short example here, let's assume that we have a firewall and a network security monitoring sensor. The first one captures the client IP address as host_address, whilst the second captures it as client.ip. With the Elastic Common Schema, this can be mapped to the same field. So if we write a search for host.ip, for example, we'll find data for the client machine from both firewall and network sensor. Now that we have covered the log consistency aspect, it's time to move forward to the Elastic SIEM component.